Okay, first of all, I want to apologize for the sound. I'm on my laptop, and the microphone really isn't that very good. Today I want to talk to you how to get the square root of imperfect squares. And the method I'm about to show you works with numbers like 17 and 18, 26 and 27, 50, 51, 65, 66, 82, 83, 101, and 102. Now you'll probably notice that these numbers are the two natural numbers immediately above existing perfect squares. For example, 17 and 18 are immediately above the perfect square of 16, which of course has a square root of 4. You can pause this video at any time if you'd like, just to confirm that that's true. In another video, I'm going to show you how to get the square root of 42, which, by the way, is exactly midway point between two perfect squares, 36 and 49. And yes, this method will work for all natural numbers, exactly midway point between two perfect squares. But for now, I'm going to show you today how to get the square root of numbers 37 and 38. So let's get started. Now at the top of this document here on your screen, you'll notice I have 36 equals 6 times 6. And this is important because it goes towards how this method works and how we're going to find the square root for 37. It should be pretty clear that the square root of 36, well, is 6. After all, 6 squared, or 6 times 6, does equal 36. Now on the next line, you'll notice some numbers in red. So I'm going to explain how those numbers are derived, or in other words, where'd they come from. So when we're trying to solve the square root of 37, we need a number 6. It should be clear where that came from, because I just talked about it. The number 1, it comes from subtracting the perfect square of 36 from 37, the number we're trying to get the square root for. 37 minus 36, sure enough, equals 1. Now, where did I get 13? Well, the perfect square above 37 is 49. Remember, 6 times 6 equals 36, and 7 times 7 equals 49. So we simply take 49 and subtract 36, and that's how we get 13. Okay, now that you know how those numbers were derived, I went ahead and assigned these numbers to variables, because you'll notice on your screen here that we do have an algebraic expression, which simplifies things. So r is equal to 37, the number we're trying to find the square root for. S is equal to 6, n is equal to 1, d is equal to 13, and for 37, f is equal to d. Now, when we look at the square root of 38, you'll see why f is necessary. But for this number, 37, f is simply equal to d. So in other words, f is equal to 13. Let's take a look at this algebraic expression. Very simple. The square root of r equals 1 over d times f. And the parentheses here is simply so we can keep the order of operation in check. We don't want things to get out of control. So 1 over d times f plus n over d plus s. I mean, we are talking about the very pillars of mathematics here, right? Addition, multiplication, and division. That's all that's necessary in this algebraic expression that we just looked at. So now, let's plug in the numbers for these variables. The square root of r, which is 37, is equal to 1 over 169. So where did 169 come from? Well, d times f. Since f and d equal each other, we're just simply saying 13 times 13 here. You can do that in your head, on a piece of paper, or maybe a calculator or computer if you really need to. Next is n over d, which is 1 over 13. And lastly, plus s, which is 6. Now this algebraic expression yields a number of 6.082840,237. When we square that, or you can multiply it by itself, it yields a result of 37.0009. So is this number an absolutely perfect square root for 37? No, it's not. But it's very, very close and it's very accurate, yes? Let's move on to 38 and see how we do that. Well, I'm not going to go through how we got every single number here, the red numbers, because I already did that when we looked at the square root of 37, and the method hasn't changed at all. However, I do want to talk briefly about this time f is not equal to d, it's equal to 7. So where did 7 come from? Well, 13 minus 6 equals 7. We know where 13 came from. You can always pause the video here and go back if you need to really know where 13 came from. In fact, it's right there on the screen right now. And where did 6 come from? Again, we talked about that already. So 13 minus 6 equals 7. Let's go down to all the way down to plug in the numbers. Square root of 38 equals 1 over 91 plus 2 over 13 plus 6. So again, 1 over d times f plus n over d plus s. And this yields, for the square root of 38, for this particular algebraic expression that's here, it yields 6.164835165. And again, it is a very close approximation to the square root of 38. Because in reality, we could just keep putting 38.0000 and just keep going on, because we're going to get an irrational number, right? So what we're really doing is taking rational numbers and getting very close approximations for the square root of imperfect squares. Now, I mentioned a little bit earlier, which I'll do in another video, on how we can get the square root of 42, because it's a little bit different approach from what we just saw for 37 and 38. And what I didn't talk about, but I'll mention here, is I'm also going to show you in another video how we get the square root of 47 and 48, which you'll notice is just below a perfect square of 49. Now, everything I mentioned here will apply to all ranges between two perfect squares. So in other words, going back to our other document here, this will apply to numbers between 16 and 25, between 25 and 36, and as we just saw, for numbers between 36 and 49, between 49 and 64, 64 and 81, and 81 through 100, and it actually just keeps on going up. So I hope you got something out of this. Please comment, because I'd like to hear what other people have to say and what they think about this. You know, we're quickly approaching in mathematics where we'll be able to get square root of any natural number with very, very accurate results, as you saw here today on this video. Also, I do like thumbs up, so don't be afraid to do that either. I appreciate you taking the time to watch my video. Talk to you again real soon.